Kirkman. Hello and welcome back. Here we are continuing our 9.1 lessons, looking specifically at exponential expressions. We're going to do some practice problems. We're going to basically be able to solve expressions with whole number exponents. That's what we're going to be able to do. So hopefully you've watched our first video so that you know what I mean by expression, equivalent expression, exponent, power, base, things like that. So the first thing we're going to do is write the expression as an equivalent, exponent, or power. So here is our expression, which is, we're going to do the example first, 8 times 8. And what we're going to do is turn this expanded expression into an exponential expression. So because there are two 8s, 1, 2, our base is going to be 8 because that's our factor. And then our exponent is going to be 2 because that tells me how many of that certain number there are. Okay, so let's do some practice here. So I've got 1, 2, 3 4s. So my exponent is going to have a 4 on the bottom and a 3 as my exponent. Here I have a 1 singular 6. So my base is going to be a 6 and my exponent will be a 1. Over here, I've got 1, 2, 3, 4, 5, 6 5s. So my base will be 5 and my exponent will be 6. And that's the easy truth here. So now let's practice the other way. Now we're going to go in reverse. We're going to take an exponent that's given to us and we're going to expand it and then solve it, answer it. Okay? So if 3 is the number I'm multiplying by, and I need 4 of them. 1, 2, 3, 4. And then I need to actually solve this problem. So 3 times 3 is 9. And then we're going to take 9 and we're going to times by another 3 to get 27. And then we're going to take that 27 and we're going to times by another 3 to get 81. So our answer is 3 times 3 times 3 times 3, or 81. Okay, if you want to pause and try the other two on your own and then join us, you can do that. For number 2, I'm going to have 9 1s. 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. And then anything times 1 is itself. So even though I multiply 1 times 1, I get 1. Then times 1 again, and that's 1. Times 1 again, that's 1. Times 1 again, that's 1. Times 1 again. It doesn't matter how many times I times by 1. It's always going to be the original number, which in this case is 1. So 1 times 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 1, 9 times, is 1, not 9. If you said 9, then what you did was either you multiplied the base and the exponent, which we're not supposed to do, or you added. Okay. All right, and then the last one, I'm going to have 2 12s, and 12 times 12 is 144. Easy peasy. All right, in this one, you need to fill in the blanks, fill in these missing pieces. So you can pause the video and fill them in yourself, or you can fill them in with me. Basically here I've got 5 to the first power. That's just one singular 5 and its value is 5. Here I've got 5 times 5. That's going to be 5 to the second power, and 5 times 5 is 25. Here I've got 5 to the third power, so I need 5 threes. 5 times 5 times 5. 25 times 5 is 125. Down here I've got 4 5s, so I'm going to, whoopsie, 2 5 to the fourth power. I'm going to take 125 and I'm going to times that by 5. I'm going to get 625. And then finally, I've got 5 5s. So I'm going to write out all 5 of these 5s. And I know that that answer will be 3,125. Okay, moving right along. In this next problem, we are looking at fractions. So we're only going to deal with whole number exponents, but our base could be a fraction or a decimal. Whether it's a fraction or a decimal, you are still just repetitively multiplying. The only difference here, and I would write this down, is 4 to the power of 4 over 5 is not the same as 4/5 parentheses to the power of 4. Okay? You have to use these parentheses if your exponent is being applied to both the numerator and the denominator. And here is why, because this first problem is really 4 times 4 times 4 times 4 over 5, whereas the second problem is 4 times 4 times 4 times 4 over 5 times 5 times 5 times 5. Or in other words, it's 4 to the 4th power over 5 to the 4th power. This little exponent here gets applied to both the top and the bottom when those exponents are, or those parentheses are used. If you do not use the parentheses, you will not get the right answer. These parentheses are important. So let's practice writing. So here I've got 1/8 times 1/8. That's going to be 1/8 squared, or to the power of 2. 1, 2, 3, 4, 5 2/3 is going to be 2/3 to the 5th power. And here I've got 3 2/5. That's going to be 2/5 to the 3rd power. Okay, I would definitely pause and write this information down because that is a big difference, and it does not mean it's the same number if you do it the wrong way. All right, our last one is now going backwards or the other way. We're going to take our fractions with exponents and we're going to expand them out and then solve them. Now, this first one is super easy because the property of 0 says anything raised to the power of 0 is 1. So this is going to be, well, I don't know why I wrote that. Hold on. I'm just trying to write the answer. 3/5 to the power of 0 is 1. Now, the other ones are a little different. I'm going to do 1/7 times 1/7 because it's 1/7 to the power of 2. That turns into 1 times 1 over 7 times 7, which is 1/49. Same on the bottom here. I'm going to do 6/7 times 6/7, which turns out to be 6 times 6 over 7 times 7, and that is 36/49. There you go. That's basically all I have. You guys are going to have some practice problems in class and some worksheets to work on, but that's our intro into expressions, equations, and exponents. Join me again in the next video and we'll start diving down deep into order of operations. Okay? Thanks.